Chapter 3, Section 2, Sine and Cosine Ratios, Master Level. So we're just going to do some word problems in this video. So number 1, an auger is used to fill a storage container with grain. If the auger is 65 feet in length and the storage container is 30 feet tall, what is the angle of inclination? So here I have the diagram. This is the auger right here, and this is what is used to actually fill the container with the grain through the top. And the height here is 30 feet, and this is the length of the auger, 65, and the angle of inclination is this angle theta right here. So all we have to do is figure out what this angle is. Well, that's no problem at all. In fact, I'll even draw another picture. Not that I need to. So that's the angle we want to find. This is, of course, 90 degrees, and this is 30 feet. Oh, and this is 65 feet. Okay, so we have two sides, and in relation to where theta is, 30 is the opposite, and 65, of course, is the hypotenuse. So which ratio uses those two sides? Well, think SOHCAHTOA. Okay. Opposite and hypotenuse, that's the sine ratio. So the sine of whatever angle theta is the ratio of 30 over 65. Okay. So that means theta itself must be the inverse of that. Okay. So I'm just going to take out my calculator and work that out. It's pretty simple. And I get theta is approximately 27.5 degrees. And that one's done. Question 2, a 25-foot ladder leans against a wall at a 60-degree angle. How high up the wall does the ladder reach? So I have my picture here, and then within it I've drawn a right triangle. So the length of the ladder forms the hypotenuse of the right triangle. This is my theta at 60 degrees, and we want the height up the wall. So I'll call this h for height. So that's what we're trying to solve for. We have our angle, it's the opposite that we're trying to determine, and the hypotenuse we're given. That requires the sine ratio. So the sine of 60 degrees, okay, is equal to the opposite divided by the hypotenuse. All right. This one's very easy to solve for. Just going to multiply both sides by 25. No problem. I like it when problems are easy. So h is going to be whatever 25 times the sine of 60 is. Okay, and we're going to get, let's see here, approximately 21.7, and my units are in feet, so I have to be consistent. So there we go. And that should make sense. Okay, if the hypotenuse is 25 feet, there's no way that either the height or this length here could be larger than 25. Okay, so it's just under 22. Next question, it says solve for angle theta. So this is the angle we're trying to determine. We're given some information. The adjacent, okay, relative to this angle here is 14.2, but that's pretty much all we know, right, when it comes to this triangle here, which I will outline in blue. All right. But we have some information regarding this triangle, which I'll do in red, and we're given a little bit more. Okay, so we have an angle here that's 22. The hypotenuse of the red is 17. Okay, so we could either use the sine ratio to find this length right here, but I don't think that would really help us trying to find this angle here. More likely, we need to find this length right here, which is the adjacent. I'm going to call that x. Okay, because if we can determine this adjacent x, that is the hypotenuse of the blue triangle, which will allow us to solve for theta. All right, so hypotenuse, adjacent, that's cosine. So the cosine of 22 degrees, okay, that is x divided by 17. So I'm just going to multiply both sides by 17. And so x is equal to 17 times cos 22. And that works out to be times cos 22 about 15.762 1. I'm going to keep a few decimals only because this is not a final answer, and I'm going to be using this number to help me find this angle theta. So that's why I'm keeping some more numbers here. So remember, this, okay, that's also x. Right? These two sides are exactly the same. But now that we know the hypotenuse of the blue triangle and we know the adjacent, we can now use inverse cosine to find theta. So I'm going to set it up. Cos of theta is the adjacent divided by the hypotenuse, which I now know to be that 15.762 1. All right? So to complete this, we just need to find the inverse. So theta is inverse cos of 14.2 divided by this number here. So that's going to be approximately, and just going to work this out. And I get about 25.7 degrees. All right? So that is this angle right here.